Welcome to the Precast Podcast, episode 47. So we are going to continue talking about what I'm going to say are newer technologies. Again, we're focused on the precast concrete space, but there's a lot of things that go into concrete, as everyone who listens to this podcast knows. I'd like to say thank you very much to Tiffany Duffy. Tiffany, nice to have you on the Precast Podcast.
Thank you, Hugh. Thanks for having me.
Could I please ask you, could you maybe give us a short bio and maybe just a high-level introduction to carbon upcycling?
Absolutely. So right now I am the business development director with Carbon Upcycling, focusing on the commercialization of our new technology. My background is primarily based in the cementitious space. I've worked for a number of cement and alternate SCM or SCM, supplementary cementitious material marketers, specifically fly ash, lime, and slag. I have a civil engineering degree from school, but very quickly went into sales and marketing as related to cementitious materials. Really kind of my passion has been in the development of materials to help to offset the amount of cement utilized in a concrete mix or concrete product, to ultimately help to reduce the CO2 emissions. So ultimately to try to improve our environment through the utilization of these alternate materials. So I joined Carbon Upcycling recently in August in this role. It's a really, really exciting technology, Hugh. With my background in cementitious materials, I knew that the industry would continue to increase their demand and consumption of these materials to offset the amount of cement in a mix to ultimately help to reduce greenhouse gas emissions. But the supply for these materials and the quality of these materials is dwindling. When I was introduced to the technology, it was really exciting because not only could they take a low quality or underutilized feedstock and through the technology incorporate CO2 directly from a flue gas stream to enhance the performance of the material, ultimately resulting in a much more reactive material, which with greater strength activity index. So ultimately not only replace cement in a concrete mix in the traditional sense, but ultimately be able to increase the amount of consumption of that material. So to further reduce that cement and ultimately further reduce the CO2 footprint of those ultimate concrete mixes.
I have a background in civil engineering, and I'm going to say I got very fortunate. When I was finishing up my undergrad, I had been working with my undergraduate advisor in one of the laboratories at the University of New Hampshire, and he came to me and he said, "Hey, what are you doing next year when you graduate?" And I didn't really have myself squared away yet, and he offered me a research assistantship to study. I think the name of my thesis is Mitigating Alkali Silicate Reaction with Recycled Concrete Aggregate.
Okay.
So I was like, wow, okay, what is that? I learned very quickly about like Class F fly ash, ground granulated blast furnace slag, silica fume, and just again, like different things. Like, I still run into people that call concrete cement, and I'm like, whoa. We're not gonna let that go. Let's talk about cement. I mean, when you're talking, I guess kind of going back to, your background in SCMs, like would you guys, kind of be going in and working with like coal-fired power plants, steel facilities, and, are there other SCMs besides like the fly ash and the slag? I don't know that you guys are focused on, or?
Absolutely. The interesting time, the industry has been demanding the use of alternate materials and to be able to qualify those materials through the performance of that material and the end product. Standards and specifications right now are much more prescriptive, meaning you can only use these types of materials to this amount of replacement. And the industry is changing, and there are a number of reasons why. It's supply surety or supply security. There's a dwindling amount of materials to be utilized as a replacement. There are green initiatives to further reduce the amount of cement in a mix, and so they're looking for alternate ways to do that. ASTM is now considering pushing forward a new specification for specifically alternate supplementary cementitious materials. which will open the door for a large number of materials to be utilized outside of the traditional ones that you had mentioned, a Class C, a Class F fly ash, or ground granulated blast furnace slag. These materials will be considered based on their performance, and there will be some limitations related to some high level requirements, but it will allow for a number of different materials, not just reclaimed fly ashes that may have been sitting in landfill for 50 years, but anything from microsilica to low kaolinite clays, to alternate slags. And so this technology helps to allow those materials to not only be utilized, but be utilized in higher amounts because we are increasing the reactivity and the performance of those materials.
Could you bring us through? So, let's say there's a precast concrete manufacturer in in North Carolina listening to this, and they're like, okay. It's like high level. They may hear, all right, I can utilize less cement.
Mm-hmm.
I can work with Tiffany to introduce new, SCMs I'm aware of, but maybe SCMs that have been, and maybe we'll talk about this, but I'll use the word reworked,
Mm-hmm.
so that they work better and possibly get the same performance metrics that I'm used to in terms of durability. My strengths will be the same, 7, 14, 28 days. Like, if, how would you talk to them if they're like, how do you actually do this? Like, how does that process work?
Sure.
Because I mean, like, I guess like for some people, they might be like, okay, this either sounds maybe kind of fishy, might
Mm-hmm.
kind of sound like magic, or people might be like, okay, like I've been hearing about this, the technology is definitely moving in this direction, but I don't quite understand, like at the micro level, like how this actually works.
Sure. So I'll kind of talk about the science behind what we're doing, and then we can even talk about how we bring the material to market. Our technology is what we call carbon tech or material technology utilizing CO2. We refer to our technology as MACE, M-A-C-E, which means mechanically activated and chemically enhanced. And ultimately what we're doing through what we call our reactor, which is ultimately a catalytic ball mill, we introduce a stream of raw materials. So whether that is a low performing natural pozzolan, whether that is some form of mine tailings or an aggregate fine, we introduce it to that ball mill. We reduce the particle size and we enhance the surface area. So not only do we have a finer particle, we also have much more surface area that allows for the reaction with a stream of CO2. The CO2 is introduced at the same time of the particle reduction. And so that's allowing for further carbonation. And that carbonation helps to enhance the performance of the material. And then it's, once it's processed, it's sent to a receiving silo and then loaded into a truck and off to the destination. So it's not an overly complicated process. It's really a way to beneficiate materials that have a lower performance to make it a much higher performing material, and also capturing and sequestering CO2. So you get the added value of not just higher performing material, but also the sequestration or the offset of CO2.
What happens to that CO2? I guess, is that a valid, where did, how is it captured, or like, where does it go?
So it's a chemical reaction.
Yeah.
The materials that work best in our process have calcium oxide or magnesium oxide, in some cases silicates, but we have the greatest performance improvement with materials with higher levels of calcium oxide or magnesium oxide. Does not mean you have to have a super high level of it, but we see much CO2 uptake when you have higher amounts of those two materials. And it's ultimately a chemical reaction. So the CO2 reacts with those higher amounts of calcium oxide or magnesium oxide, creates a carbonate, a binder, and that's ultimately what helps to increase the performance of the material.
Okay. And again, I've done, I've kind of gone through and studied your website. I guess, is that kind of the quote unquote closing the carbon cycle?
Absolutely.
Okay.
That's correct.
Yeah.
Yes. And
Okay.
the way we look at it is not only, it's really two parts. When you talk about sequestration, capturing CO2 in the material itself, it's permanently bound there. So there's no release of that material unless for some reason it would be reburned, or there would be a release of the CO2 again. Secondly, you have to look at the application of the material and the further offset potential of cement, which equates to further offset of CO2. So we look at a sequestration and an abatement when we talk about tax credits.
Okay. I'm not sure if we'll get the tax credits today, but
no problem. Please don't.
well, no. Okay, but I mean that I'm assuming that gets into, because I mean, again, right? Let's say the owner of a precast facility, they want to make sure that they understand how this actually works. If they choose to work with you, their concrete is still going to meet spec.
Right.
And then I'm assuming, obviously, there's another part of the, that's like conversation one, like, okay, like, the quality will be the same. I'm doing something positive for the environment. And then question two is like, let's talk economics. Okay, so that's a whole different story. I'm not sure if we're going to get there today, but I guess kind of high level, are there incentives? It sounds like there might be some tax credits that are being pushed from the federal government, possibly state governments at this point, to help sway people in this direction?
Absolutely. So there are absolutely tax incentives as related to government entities. Now, right now in the US, those are all credits that are not necessarily pushed through the federal government, but there are states that have incentives as well. So there are ways to basically receive tax credits and either split that opportunity or fully realize the opportunity with the CO2 sequestration tax credit. And then by utilizing the material to abate or offset additional cement, the producer would also have the opportunity for those additional tax credits.
Okay.
Right now, it's a voluntary tax credit market in the U.S.
Okay.
Now, in countries like countries like Canada or in Europe, there are actual tax incentives generated through their federal governments. When we look at states like California, they have their own state tax credits as well. So there are different ways to go about evaluating that. Okay.
So, I live in Massachusetts. I guess California kind of seems to be the leader in bringing new technologies to the forefront. Massachusetts typically is not far behind.
Right.
Okay.
And you got to think about it too. Outside of tax credits, there are other incentives to utilize these green materials, or what's considered a green material, with the infrastructure or the Inflation Reduction Act and some other new funding through the federal government and through state governments. There are incentives and or requirements to utilize low carbon products. And so, the utilization of these types of materials helps to qualify the end product for consideration in these projects or in the funding from a state or federal government perspective.
Is there like a rule of thumb? Let's say if a precaster wanted to utilize this technology and they make like a standard, like a 4,000 PSI, a 5,000 PSI mix, could they assume that they can utilize like 5%, 10, 15% less class 3 cement? Is there any kind of a ballpark?
So it's really material dependent. And so I'll cite a couple examples. If we were to take a traditional class F fly ash that tends to have a strength activity in the 80% range, by putting it through our technology, we can enhance that material to an SAI of somewhere north of 125% plus. So we're comparing that performance, that strength activity, to a straight mortar mix or straight cement mix. So in turn, you can assume that you would make you had the potential to do a higher replacement because that material is much more reactive. Our material would be considered SCM, so it's would replace any traditional fly ash or slag that these precasters may be using. It would just be an enhanced value. So you would have not only the enhanced performance, but also the benefit of sequestering CO2.
I guess too, one thing I saw on your website was that cement manufacturers can I guess I just saw that less clinker needs to go into the cement. There's the ability to kind of reduce fairly far down the supply chain. That's like step one, and then also then less cement into the concrete. So I mean it doesn't like just start like at the cement silo at the manufacturing plant. It starts far prior to that.
Absolutely. So the cement industry has made some really aggressive initiatives to reduce their CO2 emissions. As you, I'm sure, are well aware, a lot of the industry, especially here in the US, has changed to or pivoted to a 1L, where they're utilizing limestone and replace some of the portion of clinker to reduce CO2. Now, limestone doesn't necessarily have a very reactive component to it, but instead of producing a 1L, if you were to consider producing a 1P, which would be a blend of a pozzolan, and consider our material as a highly reactive pozzolan, you can make a much more effective cement, which with a much lower CO2 footprint. So you get a better value product at the end of the day, better performing cement with a lower CO2 footprint. So that's given us a lot of momentum with the cement industry because of the way the technology can plug directly into a cement kiln, pull CO2 directly out of their flue gas stream, and utilize some of their waste materials, whether it's mine overburden or aggregate fines, to increase that performance of that material, and then utilize it in as either a clinker replacement or as an inner grind to further their production abilities.
At this time, do cement manufacturers, like, is it a challenge to work with them to get your technology into their facilities? Mm-hmm. Or are they seeing your technology as like a true partnership? Let's get this done. Like, how does that work at this time?
It depends on what partner you're looking to work with, but the largest players in the industry, or the ones that are most forward thinking, are extremely excited about the technology and are willing to work with us in a partnership opportunity, in opportunities to install smaller reactors so that we can build out a proof of concept and then help to to further the opportunity to other cement kilns. So we've seen a lot of acceptance and a lot of interest. Our backlog is growing in terms of opportunities. It's really, really exciting. When you talk about an industry, the cement industry, that produces or emits 8% of all greenhouse gases through production, and they have initiatives to be carbon neutral by 2035 or 2050. There are a number of paths. There will have to be a number of solutions for them to get there. It would be energy efficiency, the use of alternate materials, and new technologies. And so this is really one of those technologies that not only helps to reduce CO2 emissions, but it also helps to enhance their end product. And so there's a huge value in that. That's interesting. And I guess, we've talked about reducing emissions. I guess, I don't know, we've been talking about SEMs and how you guys work with cement manufacturers. Are there other things? I'm kind of going off 3 points on your website: build resilient supply chains. So, I mean, are there, as an example, when I was in grad school, I would literally drive my car down to Brayton Point in Massachusetts, coal-fired power plant, which has since been fully decommissioned. And I would put on a dust mask and fill up a barrel, but obviously not the best thing to do. That would not be allowed these days, I'm assuming, but that was my supply chain for Class F fly ash. Sure. And I know at Shea right now, we use fly ash. I'm gonna assume it's Class F, mm-hmm. and slag as well. I don't know. It seems like the ash is getting harder and harder to get based on just coal-fired power plants coming offline. Mm-hmm. I'm assuming that if it's harder to get, it's more expensive. But I mean, how are you guys dealing with or working to make your supply chains resilient? I think this is one of the most exciting parts of the technology for me, is the opportunity to provide supply chain surety or security to the end user. So when we talk about an example like Shea, who is having to work through cement suppliers and SCM suppliers, they're dependent on what is available. And I know in the past, at least 2 years, we saw a major issue with the availability of cement throughout the US. And so these are issues that the end user, if you're an independent, not vertically integrated, you're fighting on a daily basis. So our technology doesn't address the cement side of things directly, but what it helps to do is say, listen, if you have a stream of material, if you have a source of material that we can upcycle as an SCM. You've got that, you own that, you've got that supply surety. And if we can enhance the material to perform at the same level as a traditional SCM or better, then you have the opportunity to further reduce your demand for a certain amount of cement. And so that allows greater flexibility for the end user, for a shea, or for some of these other, whether it's precast or ready mix supply or producers, so that they can provide their own source of material. So it's ultimately a really good opportunity for not only just recycling and reuse, but also to at least cut the ties on one stream of material sourcing that you don't have to necessarily further rely on logistics and availability and quality. You can control that.
Mm-hmm. Are there, like, in utilizing your technology, are there now folks that have industrial facilities that, you know, that produce what was a waste product that is now able to be utilized based on your technology to actually, you know, go into, you know, concrete? Because I guess, you know, there's kind of some talk about plastics and different things. Again, I'm not sure if we're going to get into that today, but I mean, it sounds like there's opportunities for folks that once only had like what they thought was waste, that was probably fairly expensive to deal with. And now it's something that they're actually able to monetize.
Yeah, it's really interesting. We've had some incredible results with glass, recycled glass. We know that that's a major issue now because of the lack of ability to recycle certain glasses. So for us to keep it out of the landfill, that is actually the specific raw material that we will be testing and providing to Cemex in the UK for that first large scale cement deployment.
Okay.
We've had some really incredible results with municipal solid waste ashes and biomass or wood ashes for utilization as SCMs. We've seen incredible results with clays. So they do not have to be high kaolinite, high quality clays. We've seen great results with materials that have 30 to 40% kaolinite quality material. So when you're talking about a producer that may have a source of their own aggregate, or may have to clear off, you know, a layer of clay, or may have some aggregate fines, these are great opportunities for us to look at what we can do with those materials and no longer have to dispose of them or avoid disposal. We can now upcycle and use them.
Okay. Now, yeah, as we kind of drive further down, you know, talking about improving performance. So, and again, I'm kind of reading this, you know, right off your website. Improve concrete durability by 60% and strength by up to 40%, right? So I'm sure there's going to be, you know, it's like the rule of thirds. Like a third of the people are like, okay, fantastic, I believe you. A third of the people are like, I'm not really interested. And a third are going to say, there's no way they're able to do that. Now, you guys also indicate that it's all third party verified. So could you talk about, you know, kind of who does that and how we know that is true?
Yeah, no, Hugh, I'm right there with you. I'm my mind works like an engineer. Data. You know, how do we make these claims? And you're exactly right. It's through all third-party testing. So what we do is validated, not only obviously in-house, but we send everything out for third-party verification. Not just from a material, a physical and chemical standpoint. So just for evaluation through an ASTM standard, but also through performance. And we have a lot of really, really good industry contacts and technical advisors that support us in these evaluations, in these trials. At the end of the day, for me to be able to bring a product to you and say, this is going to work for you, you're going to say, how do you know? And to have the data to back that up. So showing not only the improvement in reactivity and the improvement in strength activity, but also how does this material perform in a concrete mix or in a concrete application, both from the plastic and hardened properties. When we talk about durability, obviously we're talking about material that has had a reduction in size. And so finer material tends to make a more dense, durable concrete. So we look at that. We look at ASR mitigation and chloride mitigation. And then we also look at, like I said, performance from a reactivity standpoint, a strength activity standpoint. How does it compare to a straight mortar mix? How does it compare to other materials that are in the market so that we can best position and best educate our potential end users on what this material is. At the end of the day, it's all dependent on the material because we have such flexibility in feedstock. We have to look at it separately. But everything that we not only evaluate from that first pass, but as we get further down into our evaluation process, it's all tested for performance and true application.
Let's say that, there's a cement producer listening that maybe has not spoken to you and your team yet, and did not know that carbon upcycling existed. If they were like, okay, I'd like to give this a try, they can see what, your reactors look like on your website. How, what's the typical process of getting your equipment installed at a cement manufacturer's facility? Are they purchasing it? I don't know, is it being leased? Is it like a partnership where you guys just bring your equipment in? How does that typically integrate and work?
So as we start to deploy our first units out for commercial application, our preferred method of commercialization is through a tolling arrangement where we would fully fund the system, build out at whether it's a cement kiln or at a ready mix facility or at a precast facility, and then we operate it. So everything is built out as a tolling arrangement. So we process the material and then we sell it to the end user through tolling. As we kind of get a few of these units out and under our belt, then we will look at consideration of leasing arrangement or direct sales of the equipment. But as we get those first few out for commercial operation, we want to keep our hands on to make sure that we're working out any kinks and aware of what's going on. The equipment is very, very easy to operate. It really doesn't have anything to do with a complication of operating the machinery or the equipment. It's really just making sure that we feel confident that as we're deploying these first units, they fully work. So a tolling arrangement at this time is our preferred method.
Okay. So it sounds like there's no large capital outlay to start this a partnership with your company.
It's exactly right. So we can work through a number of different commercial models. The easiest being we fully fund and operate. And then there are ways that we can work closer in a partnership where there are some shared funds involved in the deployment of the technology.
Great. Okay. All right. So we're gonna start to wrap it up. What was the company started in 2014?
It was.
Okay, so it's been, this is, how old is the cement industry? Thousands of years, right?
Yes.
So,
right.
Okay. All right. So, it's, in less than a decade, then it's gone from initial concept to now deploying, and working with, you said CEMEX, large players in the concrete, cement, ready mix, precast space. That's exciting.
No, it's really exciting. So you're right. So the technology was started back or founded back in 2014, and there were a number of different concepts that were considered in utilization of this carbon sequestration and carbonization technology, and they ultimately landed on what can we do and how do we reduce greenhouse gases in the cement industry? Not going away, very hard to abate sector. We also have applications for consumer goods and for plastics, which is really exciting. But to be able to deploy in that cement sector, I think is the most effective way for us to do it. We were involved in the Carbon Xprize and were awarded the Carbon Xprize and had the opportunity to build out a facility in Calgary, Alberta, Canada. And that's what allowed us to do a number of different advancements with our technology. Number one, we were able to scale up our technology 10,000 times. So we were working with reactors in the gram size amount of material. Now we are deploying 50 tons per day, 200 tons per day. So the amount of scale was huge. We were initially utilizing pure streams, what I call merchant CO2, that you would buy from an air gas or a Praxair. But because of that opportunity to work at that site, in Calgary, we are now able to directly pull material or pull CO2 directly out of the flue gas stream. So we no longer need a carbon capture unit. We no longer need a high purity source of CO2. So that allowed us greater flexibility. And that's what really is exciting about the technology. We can work with a number of different feedstocks. We can work with a number of different types of CO2 or streams of CO2 to ultimately enhance the performance of that material.
Like, is your group currently active, like directly with like ASTM or, you know, other specification entities, you know, in either revising or creating new specs? Is that also something you guys are tackling?
Absolutely. So we're trying to be involved in as many industry associations as possible. Obviously, ASTM, NRMCA, PCA. We're also working on helping to revise the standards for life cycle analysis so that we can develop our own type of LCA that is specific to SCMs. And then we are trying to be as forward facing as possible with our potential partners or end users. We will actually be at ConAg this March, and we'll have a booth. We're actually invited to be a part of their innovation section. So we'll have a booth there right in the central hall, which will be really, really exciting. It's the first time for us to really be engaged in an industry event that large and really reach a number of different end users or partners. So I'm excited about that.
Want to thank you again. Great connecting again. I will make sure that your contact information is on our podcast episode listing. You know, everything, folks can listen to this right on our website, and then also on, you know, any podcast platform that, you know, they enjoy listening to podcasts on. So thank you again. We'll get this out shortly, and I'll look forward to you know, touching base and seeing how things progress for you. So again, thank you very much. Thank you to our listeners. We'll look forward to touching base.
Thanks, you. Thanks for the opportunity.